In our experiment, we decided to calculate how much energy would be lost to forces such as heat and sound as we roll down our toy car on a track and after it hits a spring. We first decided that we need to find the coefficient of friction with the track, and in order to find the coefficient of friction, we decided that the equation would end up being v squared over gd, the velocity being the initial velocity. And we calculated the initial velocity by taking the average time over a smaller distance right at the beginning as we released the car. And eventually we got a coefficient of 0.0172.
So after we found our coefficient of friction, we raised our track up by 30 degrees. We placed our car at height 1, and then we released it, and it went down at distance 1. When it hit the spring, it compressed the spring by 1 centimeter, bounced back up to a different height of height 2, then rolled back down a different distance of distance 2. After running this experiment 3 times, we found the average of all the distances and heights we needed. And to find our energy lost to heat and sound, we needed to find the initial energy minus energy lost in the track friction minus energy lost in heat and sound, and that equals energy lost in the track friction plus final energy. To expand this equals mg height 1 minus mu mg cosine theta times distance 1 plus x equals our spring compression distance, minus energy lost in heat and sound, equals mu times mg cosine theta times distance 2 plus x plus mg height 2. We rearranged the equation so we can solve for the energy lost in heat and sound. After eternities of calculations later, we finally figured out that 0.05769 joules is lost in heat, sound, and other sources. This is equivalent to 63.3% of the total energy being lost due to sound, heat, and other sources.